Yeah, I know I'm a little early. I want to figure out this this questions thing. So you know, because if it's useful, I'll use it, and if it's not useful, then whatever. It seems to me that like you know, just kind of the way that the chat, like, okay, this is my theory. This is my theory for like the question and answer feature on these streams now, is like when one is running a live stream, like in the regular sense of a live stream, it can be easy for the questions to be lost in amongst the general chatter. So perhaps this is a mechanism for highlighting something that you're putting into the chat as being a question and like queuing it up for a response or something like that, right? I don't generally think that there's a big problem with that in my particular streams, just because like most of the questions I get are like, most of the comments in the stream are questions anyways, or like follow-ups or comments on that sort of thing. So like, I don't know, I think I'm probably getting like, you know, let's just say that the number of questions in comparison to the number of like regular messages is quite high, and I don't have enough people commenting to not be able to read all of the messages anyways. So I don't think that this feature is for us, to be completely honest. The number of people in Togo Salmon has increased. Cool. Ah, you have been influential. Say hi to the Togo lecture hall. Greetings to Togo Salmon, room 120, I think. One of my first lectures ever, when I was an undergrad such as yourselves, occurred in the very room which you are now sitting. I believe it was calculus. So I will say that if you want to participate in the chat, you're going to have to log in through YouTube. So, you know, unavoidable consequences. But thank you, Peter, for making that nice for everyone. So, I'm going to run an experiment today with the stream. I'm going to try using the questions feature. All right? So, when somebody sends a question, like I'll when I ask for questions, I'll try to remember to like periodically review the questions and like answer the questions as they're being, like, I'm gonna try to do that. So yeah, you were our first lecturer, so the same, I guess. Yep, absolutely. I'm gonna try using the question feature. If it doesn't work very well or is like too cumbersome or whatever, I just won't bother. But I think we should give it a fair shake, don't you? So, good. Cool. So let's let me just pull up dump classes. Okay, so dump. So we talked about EQ and string at this point. So we need to keep moving. Good. So, jump, blurp. There we go. Questions. Is this working? Select question. Yes. It is working. So, so we talked about printing objects. We talked about equality comparison. So let's move on from there. We've talked about inheritance a bit, insofar as we were taught insofar as the example from the beginning where we were defining customized exceptions used inheritance. We used inheritance to grab all of the existing data, all of the existing variables and methods already defined in the exception class and apply those to our new class that we were defining, myError. Once again, I'm going to probably lean into C++ terminology here because I believe it's more clear. So that's actually the same terminology being used here. Classes can be used to create objects and to define new classes by inheritance. All the definitions of the base class or parent class are inherited as if they were copy-pasted. So, for example, let's just say, for the sake of argument, we wanted to define a new class for points that have an additional attribute, which is color. So let's imagine, we're graphing something, and rather than just plotting, black points in space, we want to be able to plot red ones and yellow ones and green ones, etc. You could do a similar thing with like point shape if you were to follow this analogy through. So we don't want to have to re-implement everything that was in our point class. Remember that, like, copy and paste, there are appropriate uses of it, but in general, you want to use it. You want to use it as little as possible for this type of thing. You want to create references in the program to previous parts of the program, rather than just copying and pasting the source code itself, because that way, colored point will carry any updates that occur to the normal point class, and we'll show you how this works. So, let's say we wanted to define class colored point, and we shall use the we shall use the King's Own English, and put the U in there. So, in this case, colored point is the derived class, and point is the base class. So colored point is being derived from point, which is the base for this derivation. We define an initializer, which acquires self, x0, y0, and color, again, spoken in the King's English. Self.x, self.y is equal to x0, y0, just the same as before. Self.color is equal to color. In addition, we can add a method, which is an operation on colors, def darken self, self.color is equal to the string dark prepended to self.color. So in this case, we're going to be storing colors as if they were colors as strings. So what goes in the parent after the class name? Yes, these guys here are they are arguments to the constructor. So in the same way down here, when we declare a point with coordinates 4, 7, now we're going to be declaring a point 4, 7 green, for example. So let me just check my questions. Yep. Okay. Would it be possible to use the point class, base class, and add the color parameter without redefining the entity of init? No. Well, yes. Yes, it's possible. So let me explain what's going on here. Did I spell correct color incorrectly? I did. I used the American bastardized version instead of the King's Own English. Thank you. Truly, American cultural imperialism is the worst thing currently in existence. So, So let me explain how this works. All right. If I had a blackboard, that would be ideal, but I'll just do a quick drawing, right? Well, actually, maybe that's not a great idea. So let me just get a new text pane here. So you have to imagine this is how it works, right? So inside of main, you have various definitions of various things declared. I don't think that the question thing is like actually working because there we go. Yeah, okay. I'm shutting down the questions because this is bad. Questions and Q&A. Our constructors are like point x0, xy color, right? Please re-ask your question so that it appears in the regular thing, right? Why do I have to take x0 and xy in as parameters? Aren't they part of self? No, they're distinct. So these are input parameters, right? Notice the lack of zeros on these. These are attached to the class. These don't exist outside of the constructor. All right? Is our constructor like point x0, x1, x0, x, y0 color? No, just the last three. Just the last three are the ones that you have to use during construction. What is parent? In this case, there is... In Python, they call it super. I think they call it super. So colored point would be a superclass of point, I think. But so anyway, let me go on to this analysis, right? So we have main. Main has point declared, right? Point has we have point and we have colored point. Right? Those are classes that exist inside of main, which is itself also a class. Point has defined things like init, things like distance 2. Right? Colored point, right? When you provide a definition, so colored point, when it's inheriting from point, right? Basically it says... it still has init defined, but it's defined in point, right? By default, presuming that, like, let's imagine that we didn't have this method here right now, right? Let's say we didn't have that method, we just had darken. We would have access to distance 2 as well, but it's defined in point, right? Then we have darken, which is defined in colored point in the same way that distance 2 is defined in point, right? So when you provide a definition inside of colored point, it will use its own definition of the method over that provided by a different method, or provided by a method that it's inheriting from, right? So, so init does not necessarily have to exist. Color could be added in other ways, but in general, we provide this. So to the question earlier, do we have to include everything? Like, this does seem to still have some copy-paste about it, right? These lines here essentially have been copied and pasted down here, which is a thing that I said we shouldn't do. There is a way to refer to the initializers of other classes that you're deriving. This is the way that you do it in Python. You say point dot init x0 y0. So you invoke the base class's constructor, providing it the arguments it expects. So, the way Python does this seems confusing. Tell me about it. In different terminology is point to the parent and colored point to the child. Yes. Yeah. So main is the parent of everything, right? It's like, yes, point is the parent and colored point is the child, but it's not, it's not quite that strict. The preferred, like, there's a reason that the preferred terminology here is base class, derived class, right? Inheritance is not, like, I'll talk about the difference between inheritance and, oh, what's it called? Blanking on the name for it. Oh, no. Composition. I'm going to talk about the difference between inheritance and composition, despite the fact it's not on the slides. Yeah. But yeah, in general, you may consider point the parent and colored point the child. That's probably terminology from a different language like Java or something, I would imagine. A superclass in Python is a base class. Subclasses are derived classes. Thank you. Thank you, Village. Village is our resident Python expert. To use distance to from colored point, we have to have the same number of parameters. Yes. So colored point receives the definition of distance to from point, and it receives it in exactly, like, it's exactly the same as it would be in point, right? In fact, I can do a demo, but I'll do a demo of this. Let me just clear up the questions. So you can have a colored point class. Instead of init, you just have a method which will add the color. In theory, yes. Until such method is called, though, color will be undefined, which means that it should properly be part of the constructor, probably, so we've put it in the constructor. If you call init on a parent manually, you need to pass in self as well. Oh, do I? All right. I'll take your word for it, Village. He's the Village Python expert. The better way to run base class init would be to use super color point self. Yeah. 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 We're not going to get into it, though. I understand that this is probably not optimal Python. So, anyway. So, using all of this, right, we can create some new points. Let's say E is equal to colored point 3, 1, red. F is equal to colored point 9, 2, yellow. G is equal to colored point 3, 1, green. E dot darken, print E dot color, print A dot distance to E, print E equals G. So, yep, puns aplenty. So let's run this. Oh, I forgot my braces. Terrible. So, First, we may notice that calling the darken method will indeed append the word dark to a color, and this is kind of funny because you can just, you can chain these together like that. Oh. I think I need to put some braces in there. Maybe this. Nope. Ah. Oh, it's doing it on the call result. All right. E.darken, E.darken, E.darken. There we go. That will work. There we go. So you can see that, like, if I call it 3 times, I get dark, dark, dark red. Right? Darken doesn't return anything. Yeah, I know. One thing that's interesting to note, just because, this is Python, calling the distance to method from an object of the point class, which receives an object of the colored point class, that still works and produces the correct result. Right? And one other thing that we may note, we've got E and G here, right? One red point and one green point. These are, according to our current definitions, these are the same thing, right? An equality comparison between E and G comes out true, despite the fact they are different colors. Now, maybe you don't care about color with respect to equality comparison, but if you did, you can provide a new definition for, equality comparison, taking this into account. Right? You can do something like return. What is the better way you said? Super colored point. Is that a comma? I think that's a point. Dot self. Dot init. I'm just checking to see if this works. Not init. What am I talking about? EQ. Self other. Or no, just other. And self.color equals self or other dot color. Let's see if that works. Did I use it correctly? Colored point has no attribute self. Must have been a comma. Yeah, there we go. So, yeah, thank you. Yeah, I figured it out. So basically, the idea is with a derived class, everything will default to the definition in the base class, and if that doesn't fit your situation, then you can overload the existing definition to do a more specific thing. So this is good. So the concept, yeah. Let's see here. So the concept of inheritance in object-oriented programming, a lot of people sort of mistake it. They misinterpret inheritance as being the same thing as another concept called composition, which I will talk about very shortly. The class system using inheritance, right? The intention is to be able to represent an object and then a more specific instance of the same object, right? So an object and then an object with additional properties, right? This is the concept we're trying to do with inheritance. So, for example, if you were to take this sort of hierarchical diagram of things, right? The most general thing, at least with respect to material reality, is a material object. Material objects can be divided into animals and plants, right? So both animal and plant would inherit from material object. They both have, for example, positions in space, which material objects have. Animals might be classified into mammals, fungi. No, fungi is a different kingdom. Mammals, fish, crustaceans, etc. A mammal has all of the properties that an animal has, but some more specific properties, right? A platypus has all of the properties that mammals have, with some exceptions. Dog has all of the properties mammals have, and then some additional ones. Humans have all the properties mammals have, and then some additional ones, right? So you follow this down, and eventually you get to the level of like the individual enacted thing, right? So in a sense, all of these are abstract classes except for this final row here, right? Can we talk about super, as I think it's something you have to use in the future? No, you don't actually have to use it in the future. You can use the version that's in the slides. That'll be perfectly adequate for anything that you need to do. I was just testing that to see if their claims that would work are true, and it turns out that it was. Yeah. I'd be interested in an explanation as to why super is a better way to use it. But I wish to allow dog to inherit dentist. Dog would need several attributes before he could inherit dentist, like thumbs, maybe. Ability to use tools would be a important one to have if you wanted your dog to be your dentist. But yeah, so that's the concept of inheritance. So going back to our colored point example, a point that has a color attribute is a more specific type of point, right? It has more features than just a regular point does. Thus, it is a derived class from some base class. This is to contrast with the concept of composition. So, there is a difference between something being a more specific version of the same concept and something being composed of a smaller part, right? So, while a colored point is a more specific type of point, if we wanted to use these points to construct something, like, for example, a triangle, just to pick a random example, that's something else, right? So that's a different concept. That's the concept of composition. So let's imagine, let's create a new class for triangles, right? So class triangle. We're not going to have it inherit from point. Def init self, and we'll take, actually it would be fine to take points as arguments here. Self dot point self dot let's just mix these up a little bit and call them x, y, z. Self dot a is equal to x. Self dot b is equal to y. Self dot c is equal to z. All right. So if you want, you can then define methods over it, like perimeter, right? Self, just take self, and that would be return a dot distance to b plus b dot distance to c plus c dot distance to a, right? So I'm gonna see why super is something you should use. Super automatically looks through all base classes to find what method you're looking for. This makes it easier to keep for the developer, as you do not need to keep track of which class contains the method you are looking for. Oh, yeah, okay. Super doesn't rely on knowing the inherited class specifically. Okay. Within the inner workings of Python, each class has a list of all the classes it inherits from. Super goes through this list. Okay, yep. Yeah, so it helps with abstraction then, yeah. This means that if point inherits from some original class, coordinate or something, then calling super with colored point would check that class as well. Okay. Right, okay. Huh. Oh, there you go. Interesting. Yeah, the slides should be updated at some point. I don't know, it's like, that's kind of like, I can just imagine, like, I'm just imagining the brain of some poor econ student frying if I were to put that in the slides, you know? I feel like there's too much information to absorb in a short amount of time. Welcome to university, my friend. Welcome to university. So I want very plainly to distinguish between these two, right? So colored point uses inheritance, right? And class triangle uses composition, right? So under inheritance, colored point is a more specific type of point. Under composition, a triangle is a thing that's made from other objects, right? So, you know, and like, you know, this is I'm not sure this is correct syntax, but like x, y, and z are all points here, right? So if we wanted to take, you know, try A is a triangle composed of points A, B, and E, right? And we said we wanted to print try A dot perimeter, right? Then we get the perimeter, right? Triangles are composed of points, but they do not have like all of the points available to them except through the access that they might perform internally, right? So, for example, if you were to print something like triangle A dot scale by 5 or something like that, this results in an attribute error. There's no attribute scale, right? Despite the fact that we have a scale method inside of the point class, triangle is not inheriting that method. It doesn't mean anything with respect to a triangle. In theory, you could write the scale, you could overload the scale method so that it applies that argument to a scale method of all of its child objects, right? That's fine. But with respect to, you know, with respect to just the class itself, this is currently doesn't mean anything because it's not inheriting from point. Right? How does it know it's made from points unless the perimeter method is called? It doesn't, because this is Python! Yeah, in theory, you can put like type attribution tags inside of the arguments here, but type attribution tags aren't even a thing that's covered in this course. So, yeah. What if you were to construct it out of integers? Well, it's kind of fun, right? Let's just break Python for a second, right? Let's say we have a class for butts, all right? And it just has like a definition for distance to, taking self and other, which just returns the string fart. All right. So that should be capitalized. Whoop. Capital B. There we go. So then, if you wanted to say, Q is equal to butts, R is equal to butts, S is equal to butts, butt triangle is equal to triangle of butts, right? And then you printed butt triangle dot perimeter. Any guess what we're going to get? Oh, I have to remove this previous error. Oh, that's interesting. How's it? Why is this not working? It just checks at runtime. You can pass anything everywhere, but when it's running, it gets real cranky if a method is missing or something. Yes, indeed. Everything is done through dynamic checking. So has Python been updated? So this is like, maybe I just didn't save it. No. Weird. Let me just, okay. I have to figure out what's going on here, or else I'm going to go mad. A is not defined. I never asked for A. What? Not referencing self. Triangle perimeter method does not reference self. Oh! I hate Python so much. I hate it so much. I hate it. 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 I hate Python. I hate Python. I hate Python so much. So if it doesn't exist, it will just refer to global then. Yeah, wow. Okay. Uh-huh. Yeah. Ooh. Alright. Anyway, the humorous example I was trying to get is that, so if you have a triangle which is defined with points, which have distance to defined as, Euclidean distance, then, you get something that looks like a real perimeter out of it. But if you give it 3 butts instead of points, and then butts have a definition for distance to, which just returns the word fart, and you call butt triangle dot perimeter, you get fart, fart, fart. So there you go. So, why don't I need a def init for that class? Because it doesn't have any parameters, right? Or it doesn't have any variables, right? What the init method does is it just sets, it gives you a place to set the initial values of variables, right? The variables that are tied to the object. I don't have any in this case, so I don't need an init. It's kind of similar to where, like, we were, class custom exception and inheriting from exception, right? We just said pass. We didn't actually, we didn't redefine init or anything like that, right? It's possible to make an empty class, right? Or a class that contains nothing except what it's inheriting from. And, of course, even though these braces are blank, all of these, every class automatically inherits from a base class built into Python called object, which contains various definitions for various things, like what does it mean to print this thing as a string. So there you go. So what is wrong with it precisely? Nothing's wrong with it. This is actually expected behavior. I'm just demonstrating that these guys can be objects of any. They can be objects of any class, so long as that class has the methods defined that are being used. It will just use them. This is in contrast to sane programming languages, which would require these things to be of a particular class or a group of classes prior to being initialized, so that you're not filling this guy with garbage and nonsense. The whole point of this humorous example was to show you that this can be used for evil. So there you go. So, good. Right. Fine. Excellent. So that's the difference between inheritance and composition. So inside of our computer space, colored point inherits from point. Point inherits from object. Colored point therefore inherits object through point, but it also, because all things inherit object, it also inherits object. Where am I going? There we go. You can check to see if an object is of a particular type using the type function, right? So the type of P in this example is point, right? It actually returns a reference to the class itself rather than like a string or something. So P is point, Q is colored point, but type Q equals point would fail. Type does not recognize point as being one of the things that it is. So rather, we have a different method, isInstance, which tells you whether or not X is an instance of a particular class respecting inheritance. So isInstance P applied to a class name will return true if that if that object is an object of that class or any object that class inherits from. So in this case, P is a point and is an instance of point. Q is a colored point and is an instance of both colored point and point. Could you use type to get the class and construct a new object? Yes. You can also do things like, if you wanted to avoid the issues that I was showing you, right? You could say something like, if type x, if not type x equals point, right? Or if not is instance x point, right? Then raise value error or something like that. And if you do that a couple of times with x, y, and z, that would be one way of guarding against abuse. I think this is probably not capitalized. Yeah, there we go. It's blue now. That would be one way of guarding against the butt fart scenario. How many times are you going to hear that in your classes, I ask you? So using, like, you can use these to restrict things programmatically, so that, you're only taking into your class things that are of appropriate other classes. So it's a way of guarding composition. Other programming languages, better programming languages, do that by default. It's just baked right in, and it's caught statically rather than dynamically. But we're learning Python, and Python is Python because Python is the worst. No offense to you people who are, I hope no offense to people who, are very good at Python. I hope that you recognize that there are other languages that handle this stuff better than Python does. So, good. And I don't think we can cover multiple inheritance in 2 minutes. So, I'm going to open the floor to questions. Do you have any questions? And I will answer your questions. Could you use type to get the class and construct a new object? I think that's a different question than what you were actually asking, wasn't it? So let's say something like temp is equal to type of q. Could we do something like t is equal to temp? Something like that. Would that work? I don't know. Let's see. Oh, got to get rid of the value errors first. Print t dot distance 2. Do we get that? Oh, distance 2, none. Yep, that works. You can actually pull the type of an object and then store that to a variable and use that to create another object of the same type. So, questions. What does it mean that the final is open book? Who said that the final is open book? The final isn't open book. Who said that the final is open book? That's not true. Is the TA strike really happening? Seems more likely than not at this point. Certainly, we're going to have to, I'm spending the next 2 weeks making contingency plans. How would we be examined on OOP? how would the question be asked? You would be required to program, just like every time else. The syllabus is outdated. It says it's open book, if I recall correctly. Oh, well, I'll put that on my list of things to fix today. Final is not open book. Fix syllabus. Why does E equal G? Let's see here. It doesn't. In this case, that's returning false. Right? It's returning false. That was an earlier demonstration. I updated the EQ method to also test to see if the color is the same, since the color is different for E and G. Before I made that modification, they would come out the same because they have the same XY coordinates. After I made that change, they come out different because they have different colors. Are we going to be tested about what we have learned in the assignments this time? Well, hopefully the thing you have learned in the assignments is how to program. So yes, you will be tested on your ability to program. I'm not going to ask you the same questions I asked you on the assignments, obviously, because that's not a demonstration of your problem-solving skill. That's a demonstration of your memorization skill. So if you are still under the impression that what I'm expecting from you is for you to memorize the solutions to a bunch of programs and then be able to regurgitate them on a test, you should probably get with the program. That's not what I'm testing you for. I'm testing you for your ability to program, your ability to think, your ability to come up with solutions to problems in a time-limited fashion. I know we've been ripping on Python a lot, but this is a sincere question. Why would anybody use OOP in Python? So this is why Python, right? It's basically for everybody who isn't you, right? You guys who are, like, you computer scientists who are actual computers professionals, you will stop playing with these child's toys, convoluted semantics and terrible, like, just awful to try to work with stuff, and work with a real language, hopefully as soon as possible. Many other people, such as people in the business faculty, like people in the business field or people in the pure sciences, they've been lied to, and they've been told that Python is easier to use and learn than real programming languages. Enough people have believed this lie long enough for some very useful libraries to have been developed for Python with respect to data science and with respect to, machine learning and all of this. I believe it's actually the case that if you take a lot of these libraries, in the back end, they're actually running C++. Like, a lot of these libraries, I believe, are actually C++ libraries that are ported to Python rather than being Python native. But basically, many people outside of proper programming disciplines use only Python, right? So that's who uses Python and why. It's because they don't know any better, because they're not sufficiently educated in programming languages. So that answers your question, I hope. So, Before implementing EQ, why would EG return true? Why won't it check the other color in the first place itself? Because it doesn't know anything, because it's a computer, right? It doesn't know anything unless you tell it to know that. So the class itself has no concept that it, that it has some other parameter that might need to be checked, right? The class is not a thinking entity, right? In the absence of a redefinition of EQ, its definition of EQ comes exclusively from point. So it will evaluate itself as if it were a point with no color, unless you override the definition of EQ. So it doesn't think. It has no intelligence, right? It doesn't do, no programming language will do that sort of thing unless someone very clever has told it how to do that. And in the case of Python, nobody, that's like the programming language can't read your mind, right? I'm calling to my mind an XKCD cartoon. Give me a moment. XKCD, well of uncomfortable truths. All right, here we go. Just take the first two panels here, because they're the ones that are relevant to programming. So, well of uncomfortable truths. You'll never find a programming language that frees you from the burden of clarifying your ideas. But I know what I mean. It's like, yeah, but programming languages are a language, right? You have to be able to speak the language. It's not like machines are not intelligent, right? All it is a series of instructions, right? Just because the series of instructions can get more or less complicated does not mean that the machine is intelligent, which does not mean that, as you're programming, the machine knows what you want, knows what you are thinking, and can program it for you. It's like, this is a fantasy. That's a fantasy. So, all right. Well, if there are no other questions, I think that I'm going to log off here. Take her easy, folks, and I'll see you on Friday. Bye-bye.